Welcome back to our shop. This is part 2 of the epic series of our custom table build. And these tables are 4 feet wide and 10 feet long, and we're just cutting out all the pieces to make them. Now the customer wanted them to be 10 feet long, but our material is only 20 feet, so we actually ended up making them 118 inches long, which is totally satisfactory for the customer. It's just fine. And that leaves us just enough to cut off the ends of the material and get to close enough to the 10 feet. So we're making 2 of these, so that's 4 pieces at 118 inches and 4 pieces at 48 inches. And this slugger saw just makes short work of it. Man, I hate to think how many cuts we've made with this thing. I'm pretty sure the blade is ready to be changed. We're gonna have to start looking into that. Now it's painted right on the blade mild steel, but it doesn't really care what it is. It seems to cut through just about anything. Now the material we're using is 2 inch by 2 inch, and it's 120 wall, so that's 1/8 of an inch thick, or just shy of it actually. And at a 20-foot length, it's pretty heavy, which, you know, we're using a full stick to make the frames of this table. So this table is a pretty heavy table, and once we get done with it, it's going to be really stout, which is exactly what the customer needs. These tables are going to be going in the firehouse, and firemen are not easy on things. There's an old adage that says if you lock a fireman in a padded room with 2 ball bearings and you come get him 2 hours later, one of them's going to be broken and one of them's going to be missing, and he's not going to know what happened to either of them. So knowing that and working in a firehouse for 27 years, I know that these tables need to be stout and built to last. So that's what we intend on doing. Now this slugger saw, the miter gauge on it is pretty good, but we still use gauge blocks to set the 45s and 90s on it, because when we put those 2 pieces together, we want that to fit real nice. Make it real easy for welding and real easy to clean up afterwards. Now we're setting up this frame on our sort of flat table, and I say that affectionately, and we're using a 90-degree clamp for the one corner, the corner that we're going to start with. Now that clamp, it locks it down perfectly into 90 degrees, and so if those 45s aren't cut just right, then whatever that clamp clamps it to, it's really going to show. You can see we're just propping up the ends here just to make sure that the joint is nice and tight on both sides, and because of our air quotes sort of flat table isn't very flat, we have to use shims on either ends and the corners, and that's just something that we deal with. It's kind of like an old car. You just kind of wear into the car with the car, and you're used to all of its little nuances, because that table's been with us for quite some time, and I don't know, I think we got maybe about $150 into making it, so we just deal with it, and it works well for us, at least for now. So we're using a 6-foot level, and we're just shimming up either ends of those corners, or those ends, and we're just making it nice and level. So I'll take the level and I'll put the shims underneath it, and then once I get it to where it's level, then I'll throw the shims underneath the piece of steel. It just makes it super simple. And as you can see, that joint is nice and tight. Makes it really easy to weld and gives us a good opportunity to put a nice weld in there, and once we get it cleaned up, it works out really well. And that's a good shot of that clamp. Now that's a 3-inch, 4-inch clamp. I don't remember, I've slept since then. But however, it works well for 2-inch and 3-inch material, and it's super heavy duty. That whole base is cast iron. The Acme screw part of it is copper. I mean, there's times where we just hang the grounding clamp right on that piece of copper and weld up that joint, or weld up the joint, and it works real nice. We're really pleased with those clamps. That whole clamp, I think, weighs like 20 pounds, which is nice. Now you may notice those dark stains on my shirt. That's because, this is probably about 10 o'clock in the morning in the shop, and the temperature in the shop is already 117 degrees. Yeah, this was a hot one. And then we add welding to it, which, you know, doesn't make it any cooler. And you can see we're back with that 6-foot level, and we're just leveling out that whole tabletop. So once we get those 2 corners done, You saw we had the two L's essentially, and we're putting them together, and we're just leveling up the whole piece. We're gonna make sure that piece is level from one corner to the other, and then we'll cross tape it, make sure it's nice and square, and then we'll finish welding it all out. And because we took the time and make sure we cut those 45s just right, in that when we clamped them together, there was a nice tight joint, it cross tapes and it's perfectly square. Now, setting this whole thing up and making sure it's nice and level is an important part of this build, because we don't want any twist in that frame at all. If there's any twist at all, it's going to screw up the whole tabletop. Now at this point, we haven't decided if we're going to do an epoxy pour or glass top on the table, and to be quite honest, sitting here right now, we still haven't figured that out. You can see here us just stretching the tape from corner to corner. Now I tell Dan on the one side, I don't care where you put it, it doesn't matter, just put it at the same on both ends or both corners, and then I do the same, and as long as those measurements are the same, then you know that it's nice and square. Then it's just a matter of welding out those corners, those joints. Now this side isn't clamped, but that's the bottom side of the joint that was already clamped. So we know that it's nice and square, or that the corner is good, and we're just welding out the bottom side. And because this is the bottom, we're gonna clean up that joint, but it doesn't have to be super critical or super clean. So this is just back to some grinder work, and we have a flap disc. I think that's probably about 80 grit in there. And again, even on stuff like this, I like to use one that's a little bit worn in. It just gives me a little bit more leeway. If I lean on it too much, I won't cut too much material out. And you can see how important it is to get that joint nice and tight, because we weld that out, and just with a little bit of simple grinding, it's nice and flat and smooth. Now it's just a matter of flipping this thing around and doing the same thing to the opposite corners. Now once we have both tabletops welded out and we ground down those corners so they're nice and smooth and flat, I'm just taking a DA sander now. That's DA, which means dual action, and it's a 6-inch sander, and that round 6-inch pad, it actually goes round and round like in a circle, but it also goes left and right or up and down, which gives it the dual action part of the sanding process. Now I have some 120 grit sandpaper on there, and I'm just going over the whole piece. Now we're gonna do like a machine finish on this, and at least I think so anyway. So this process here with the 120 grit going over all the exposed edges will give it that nice machined look, an industrial look. We may end up antiquing this or going a darker finish, but again, we just haven't figured that out yet. The customer's given us artistic freedom, if you will, and you know, sometimes that's a good thing, sometimes that's a bad thing. We enjoy it from time to time, and on this piece we really did, but when it gives us all those options, it kind of makes our head hurt sometimes trying to figure out what exactly we want to do. I mean, there's no pressure. These tables are only going to be in the firehouse for another 20 years or so. And we'd like to hear you guys' thoughts. If you think that these things should be machined or have that machine industrial look, or an antique like darkened finish, let us know in the comments. We'd appreciate hearing from you. Now I'm just taking some red Scotch-Brite and going over the whole thing. That DA, it left kind of a shiny finish to it, so this Scotch-Brite, not only one is it dulling it, but it's also blending in a lot of the machine finish from the DA. Whoops, almost lost it there. And that wasn't the first time. I'll give you a rough overview of what we're going to put in the middle or the inside of this frame. We're going to take some particle board, and then we're going to put laminate flooring type material on top of that. And then on top of that, we're going to put We're gonna plasma cut and put some sort of logo. They haven't really decided what they want to put in there yet. It's either gonna have the station numbers or the department logo. This is something that they're gonna decide, and they haven't quite decided that yet. But that's gonna go on top of the laminate flooring or the laminate wood. And then we're either going to do an epoxy pour over that or glass. And again, we still haven't decided about the epoxy. One thing on our mind with the epoxy is the temperature in which we're going to pour it. At 8 o'clock in the morning or 6 o'clock in the morning in the shop, it's going to be over 90 degrees. And some of that epoxy is temperature sensitive. So that could be a problem for us. But that's tomorrow's problem. And today we're just working on this. Cleaning up these pieces with the DA. Life is good. Another thought on that epoxy is once we pour that epoxy over the top of it, it's there forever. And one thing firemen are notorious for is putting a hot pan right off the stove right on the table. And if that were to happen, we'd hate to see the tabletop to be damaged, because once it's damaged, I mean, that's going to be it. So stay tuned for part 3 of this build. We appreciate you watching and subscribing. And check us out on Instagram and now LinkedIn. Thanks again.